x square plus y square. Now, karon kini dire, we also compute what we call the equivalent polar moment of inertia. Just imagine nga instead of the bolts, we now have columns. Okay? So, mga columns na ni. Column na siya. Okay, siya, column na. No? Imbis nga bolt, column na siya. Yan mo sa no? So, in lieu of the bolts, we have the columns. Now, what is the difference sa iyang behavior? Now, for the bolt, since they are used to fasten the plates, no, which are in contact, so the bolts are relatively short. Okay? Ang mga bolts, duha magkapit na ginana, i-connect na yung mobile sa bolt. Mupuro kayong bolt, di ba? So the bolt will undergo a shear deformation as you rotate one plate relative to the other. So the bolt will be subject to a shearing force, no? Which is actually the resultant sa direct shear o sa torsional shear. Okay? Pero sa building, instead of kani siyang plate mo ng mga floor level ato na siyang ibutag distance apart, then join them together, you have the column. So as the upper floor will tend to move relative to the lower floor, so the column will bend and also they will deform in shear. Okay? But the analogy is there. No? Wala ni compute there is equivalent polar moment of inertia. Dili sa mga bolts, kundi sa mga column. No? So ang bolt, shear ang iyang deformation sa column, dili lang kay shear, kundi dili na sa bending deformation. No? So this is the formula for the equivalent polar moment of inertia. So you have yr square rx over e plus summation xr square ry over e. So xr and yr are the x and y coordinate of the element referred from the center of rigidity. No? So let's ning hulaman nagbalik. So for example, ang atong center of mass na dire, di ba? Ato na ning locate yun. Ang atong center of mass. Samtang ang atong center of rigidity, itong gamiton sa center of rigidity kanilang sigurong rectangle. Center of rigidity is located here, no? That is the location of the center of rigidity. So it is not surprising to obtain, no, center of rigidity to the right of the center of mass, because the column here are closely spaced compared to the column at the other side. Diba? Nga rin spacing 8, nga rin 6. So the column are crowded. Ganun talang, no? Are more closely spaced on the right side compared to the left side. So it will pull the center of rigidity towards this closely spaced column. No? Tapok man sila. Diba? Parehago ninyo magtapok. No? So kusgan. No? Kaysa magkatag mo. Okay. So karon kanina siyang bag-o na to nga axis of reference. Kuan taog kanang nay arrow. So mo ni karon nga atong x. Kani mo na ning atong y. So ilocate na to ang element 1 gikan ining bag-o nga reference point. Kani atong ilocate from BRP, no? Now we locate it from the center of rigidity. Okay? So, testingan na to. Kaning 1, pila man ang iyang distance? X coordinate. Ikan ini nga origin. So that is on the second quadrant, no? So x coordinate is negative. Negative 11.5. Y coordinate, gikan dire paingon vertically, no, towards point. Element 1 is 7. na negative 11.57. Okay? So, inguna na nato na pag obtain. So once you have the tabulation for the coordinates based from the center of rigidity, then you can proceed, no? So ato na yung gikopya gikan sa previous table, kanisa copy from previous table, then you can evaluate, no, the values in this column. So this is just the square of this number, then multiplied by Ry over E. Likewise, kini siyang 0.0444, i-square nimo ni, i-multiply nimo sa Rx over E. Okay? So, mani mo masugod ang formula niya, pirahon mo na dire sa Excel, pag-abot ni buhi, no? You release the handle, and you get all these numbers, then you take the sum, no? So, mo ni karon ang summation. Kaning value mo ni summation. So, based on the formula, i-add na nimo duha, then you get your equivalent polar moment of inertia. No? Okay? So, naabay pangutana? Silent one by one. Naamoy question?